All right, today in geometry, we're going to look at section 6.4 through 6.5, which is all about proving triangles similar by AA, SSS, and SAS method. Right? So we're going to first talk about the third angles theorem. This tells me that if two angles of one triangle are congruent to two angles of another triangle, then the third angles of the triangles are congruent also. Okay? So we have this picture, triangle ABC and triangle DEF. If A is congruent to D and B is congruent to E, then angle C is congruent to angle F. Which makes sense, right? All right. So now we have the angle-angle similarity postulate. So AA similarity postulate tells me if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So this postulate says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So we don't have to prove all three angles are congruent. We only need two angles congruent to prove triangles are similar. Okay. So here it tells me if angle C is congruent to angle Z and angle A is congruent to angle X, then I can say that my triangles are similar. So then I can say triangle ABC is similar to triangle XYZ. So these are kind of like our congruent theorems and postulates, you know, SSS, SAS, all of those, where instead of having to have all 6 things in CP/CTC to prove triangles congruent, then we only had to have 3 things. So now in order to find triangles similar, right, instead of having to know all 3 angles are congruent and all of the sides are proportional, now as long as you know 2 angles are congruent, you can say that the triangles are similar. The next similarity theorem is the side-side-side or SSS similarity theorem. This tells me that if the corresponding side lengths of 2 triangles are proportional, then the triangles are similar. So this tells you that if you know the 3 sides are proportional, you don't have to check the angles. Okay, so in these triangles, if DE is proportional to JK equals FE proportional to LK is equal to FD proportional to LJ, then I can say triangle DEF is similar to triangle JKL. All right, one last one, the side angle side or SAS similarity theorem. So this tells me that if the lengths of 2 sides of one triangle are proportional to the lengths of 2 corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So again, it has to be the angle in between the 2 sides that are proportional. So here, if MN is proportional to RT, and that's equal to MO proportional to RS, and the angle between those 2 sides, angle M is congruent to angle R, then I can say that triangle MNO is similar to triangle RST. Now we're going to look at properties of similarity theorem. These properties are nothing new to us, right? The reflexive property. So we already know the reflexive property of equality, the reflexive property of congruence. So now we just have the reflexive property of similarity, which just says triangle ABC is similar to triangle ABC. Remember, reflexive, it's the exact same thing on both sides. Then we have the symmetric property of similarity. Symmetric, remember, it just means they trade places. So if triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. And finally, the transitive property of similarity. So this is like our chain rule, right? If the very first, then the very last. So if triangle ABC is similar to triangle DEF and triangle DEF is similar to triangle XYZ, then the very first triangle ABC is similar to the very last triangle XYZ. All right, so let's look at some examples using this stuff. We want to verify that the triangles are similar. Okay? So here what I have are all 3 sides. That's all that I have labeled. So I would have to do side, side, side. Okay? So I'm going to do, let's see, we'll start with the bottom, BC over MN. So BC is 25, MN is 20. Biggest number that they both have in common is 5, so this becomes 5 over 4. So as long as I get the same ratio, scale factor, right, on the other two sides, then I can say that they are similar. So now I'm going to check BA over ML. So I have 15 over 12. Biggest number they have in common is 3. So that becomes 5 over 4. So then the last one we want to check is AC over LN. This is 17.5 over 14. We want to get rid of that decimal. So remember, to get rid of the decimal, we divide by what the decimal is. So I'm going to divide top and bottom by 0.5. So on top, 17.5 divided by 0.5 leaves me with 35. On the bottom, 14 divided by 0.5 leaves me with 28. 35 and 28, the biggest thing they have in common is a 7. So 5 and 4. So therefore, yes, I could say triangle ABC is similar to triangle LMN by the SSS similarity theorem. All right, let's look at the next page. Again, we're going to decide if the two triangles are similar. If they are, we're going to name the rule demonstrated and name the two similar triangles. So number one, again, all that they give me are the three sides. So I need to check my ratios, my proportions. So I need to check BC over DF. So I get 9 over 18. That reduces down to 1/2. So I'm going to check BA over DE. It's 15 over 24. Biggest thing that 15 and 24 have in common is 3, which is not going to give that to me. So let's check a different BA. So let's check BA with FE, right? Because we don't know the orientation, right? So 15 over 30. That reduces down to 1/2. And so then I would say CA over ED, which would be 12 over 24, which would reduce down to 1/2. So if they are, name the rule demonstrated. So this is a side, side, side similarity theorem. Name the similar triangle. So I have triangle ABC is similar to triangle EFD. Okay. All right. Example number 2, they give me two sides and the angle in between them. Since they have that angle in between, I just need to check the sides. Okay. So I can check 6 over 9. Okay. So SA over TA. So I get 6 over 9 reduces down to 2/3. So then I need to check the 8 over 12. Because number they have in common is 4, reduces to 2 over 3. So yes, these are similar again, but this time it's the SAS similarity theorem. I could say triangle SAC is similar to triangle TAR. Number 3. So let's see, they don't have anything marked, but they're telling me that, remember those arrows, these lines are parallel. So remember, by parallel lines, we've got corresponding angles, alternate interior angles, all of those pairs. So let's see, this angle and this angle would be congruent because they're corresponding angles, as would these two over here because they're also corresponding angles. So we have parallel lines. We have congruent corresponding angles. Now I have two angles, corresponding angles that are congruent in both triangles. So by the angle-angle similarity postulate, I have enough to say triangle SMT is similar to triangle SAR. All right, so let's look at number 5. We know that we've got vertical angles here. We don't know the numbers here, but I know that this is the same as this, congruent. These are congruent. If these are congruent, then obviously they're going to have the same ratio or scale factor. So then I've got side angle side. So by the SAS similarity theorem, I could say triangle FRO is similar to triangle STO. Number 6, they give me the sides, right? So if I check sides, I'm going to check the 10 and the 15 together. So 10 over 15 reduces down to 2 and 3. The 8 and the 12 reduces down to 2 over 3. So now I'm going to check 7 and 10.5. Divide everything by 0.5. So then I get 14 over 21 reduces down to 2 over 3. So they are all similar by the side similarity theorem. So I could say triangle JLK is similar to triangle PNM. Right? So that's how all of those work out. Right? Let's look at some more on the back. Number 7, again, I have 2 sides and the angle in between them. The angle is 85, so I know that that is going to be similar. So let's try the 3 and the 12. Reduces down to 1/4. And the 4 and the 16 reduces down to 1/4. So by SAS similarity theorem, I could say triangle ZXY is similar to triangle KLJ. And the last one, I don't have any numbers, but again, I have tick marks. They all have the same tick marks, therefore they would have the same ratios, right? So this would be the SSS similarity theorem, triangle FRO, similar to triangle STY. Now let's look at some proofs, right? I promised you guys proofs, so what better way to end a Monday than with some proofs. So given segment AB is parallel to segment YX, prove triangle ABC is similar to triangle YXC. So they gave me our givens. Right? Again, with parallel lines come our angles corresponding alternate interior, alternate exterior. Here we're looking at corresponding angles. So this angle and this angle sit in the same spot. So I could say angle B is congruent to angle X by the corresponding angle postulate. But then A and Y also. So I could say angle A congruent to angle Y, again by the corresponding angle postulate. Or I could have said angle C is congruent to angle C by the reflexive property, right? So now I have 2 angles, so I automatically know the third. So now I can say triangle ABC similar to triangle YXC by the angle similarity postulate. Okay. So that one was kind of nice and easy. Let's look at one that's a little bit harder, right? So here they tell me that BX is 2 times XA, right? And CY is 2 times YA, right? They want me to prove that triangle ABC is similar to triangle AXY. So I have the givens, okay? So I'm just going to write out what is BA, okay? This whole thing. So BA is equal to BX plus AX, right? I'm going to do the same thing with this side, CA. I'm going to put it all in there together. So CA is equal to CY plus AY. My reason, what did I do? The 2 smaller ones add together equal the bigger one. They're segments. That's SAP, our segment addition postulate. Okay. So now, right, what do I know that BA is equal to? So BA equals, instead of BX, what do I know BX is? 2XA. 2XA plus AX. I'm going to do the same thing with CA. So CA equals, instead of CY, I'm going to replace it with 2YA plus AY. What did I do? I replaced something. I can only do that when I have equal signs. Substitution. So that's our substitution property. So now I have 2XA plus AX. Well, it doesn't matter how I write AX or XA. I can combine those. So I have BA equals 2 plus 1, 3 XA, and CA equals 3 YA. CLT, we combined like terms. Let's get the number all by itself, right? So if I do BA divided by XA, I get 3. If I do CA divided by YA, I get 3. What did I do? I divided, so that's my division property of equality. So now I can say BA over XA is equal to, instead of 3, I'm going to replace 3 with CA over YA. It's my substitution property again. So now I've got this side, it's proportional to this side, which is proportional to this side over this one. So basically I've just proven, okay, those. So I've got two sides, right? This side and this side of the big triangle, this side and this side in the triangle. There's no way to get this third side, but I know that angle. They both share that angle. So I could say angle A is congruent to angle A by the reflexive property of congruence, right? It's the exact same angle in both triangles. Now I have a side, angle, side. So now I can prove what they asked me, triangle ABC, similar to triangle AXY. Triangle AXY by the SAS similarity